Welcome, I'm Bruce Davie. I'm the CTO for Networking at VMware, and I'm joined by Scott Lowe, who's one of our architects in the CTO office at VMware. And so we've got about an hour to talk to you about NSX. And I've heard that you're quite a talkative bunch, so we've tried not to overwhelm you with too many slides here. We've just got some basic stuff that we want to put across, and if we don't get through all the slides, no harm done. I've organized this in 3 sections. So we're going to start with a kind of a recap of network virtualization as it is today. And I know for probably many of you in the room, this might be a bit of a recap, but we know there are people watching online and maybe watching this after it's been recorded who might benefit from this. So there's a little bit of an introductory section. We'll try to get through that in the first 20 minutes. Then we've got a section on operations and visibility. So this is a big thrust for us with NSX as it's now becoming a more kind of mature and mainstream platform with a lot of production deployments, focusing on how we actually operationalize NSX. And so we've got a couple of demos to show you in that section to talk about kind of the real world sort of day 2 operations of NSX. And then the final section is kind of the forward-looking part, where we'll talk about this vision we have for NSX everywhere, which is basically about how we're going to extend NSX from just managing workloads running in VMs to running workloads on other endpoints, mobile devices, running in public clouds, other hypervisors, containers, all that good stuff. So that's kind of the roadmap of what we're going to do. So theoretically, we'll spend about 20 minutes on each of those sections. In practice, it'll depend on how you want to drive it in terms of what you find interesting. Scott, by the way, has a lot of hands-on experience with NSX and many other software components that we interact with, and so I'll be drawing on him when you ask the hard questions, and we'll use the whiteboard if we need to. So, off we go. So here's NSX in one slide. We start with a data center with a bunch of physical infrastructure that is your basic servers and switching infrastructure, and we put on top of that a software layer. Everybody knows that you run a hypervisor and that you have a vSwitch inside that hypervisor. What NSX sort of adds to that sort of traditional data center infrastructure is a layer that ties together all of the virtual switches and creates what we sometimes call a network hypervisor. You can think of it really as a centralized point of control for creating network services and doing that on a highly customized and extremely easily automated manner. So we have, for example, the ability to produce on a per application basis. We can set up its own custom network with switching, routing, firewalling, load balancing. All of those things can be created using a set of API requests or through a centralized UI. And you can do that repeatedly, you can do it in an automated way, and you can do it in a way that's extremely scalable so that, for example, if you want to put every application into its own isolated virtual network with its own customized services, you can do that. If you want to create an independent address space for a given set of VMs, you can do that. If your address spaces are overlapping, that's all fine because it's all virtualized. Basically, we create virtual networks very much the same way that historically we created VMs, so that you can now have over a single physical infrastructure an arbitrarily large set of virtual networks with a very rich set of services. So that's, in a nutshell, what NSX does and what network virtualization does. And I'll just quickly walk through some of the things that people are doing with it today. So I've already made it 3 minutes without a question. Are there any questions on the first slide? You all knew all that, right? Okay. So there's been an interesting progression of how people have used NSX and network virtualization more broadly. So by way of history, we kind of started on this path in about 2007 with the forming of Nicira. And in the early days of Nicira, the problem that we identified was that people could automate a lot of aspects of running a data center, but they could not easily automate the process of provisioning networks. And so by the time I joined Nicira in 2012, we had a handful of customers who had all tried to build some kind of cloud service, either private or public, and had run up against the fact that they could automate the provisioning of compute pretty well, but the networking piece turned out to be a long pole. So once you got the provisioning time of a VM down to a minute or two, the fact that it now took you, weeks or months to provision a network became a really big problem. And no amount of scripting and process improvement could fix the fact that networks were just really hard to configure and manage. And so all of our early customers were people who were struggling with that automation scenario. And once we introduced a solution where you could go to a central point of control, issue a set of API requests, and spin up a virtual network with switching, routing, firewalling, et cetera, and do that with just a set of API calls into a single point, that now made it possible to automate networking the same way we had automated the provisioning of compute, or the way really the invention of the hypervisor had made it easy to automate the provisioning of compute. So that was where we got started, and that kind of took us through the first couple of years of network virtualization. And then an interesting thing happened around, say, 2013, where a few things came together. One was that there were a lot of high-profile hacks. Lots of companies like, Target, Sony, Office of Personnel Management, et cetera, all had these hacks that had this kind of common thread, which was that somehow the attacker got through the perimeter, got inside the data center, and then once inside the data center, the attacker was able to move laterally from one system to another, often over a period of weeks or months, before actually getting to the system that had the critical data. And so there was this recognition that we'd built, the sort of crunchy exterior, soft, chewy interior model that made it just way too easy. If you could just get one piece of malware through that perimeter, you had a lot of time to explore the interior until you found the data you were looking for. And so that sort of scenario, combined with the fact that we had just made it very easy for people to create lots and lots of isolated virtual networks, came together. And then in what was kind of the sort of, I guess, really good piece of fortune for us was that we also shipped a distributed firewall around the same time, so that we could now say, not only can we create an isolated network sort of on demand in a matter of seconds, but we can also put distributed firewalling inside that network. So now you can say, these VMs should only talk to each other. If they do talk to each other, it should only be on this port. And so all of a sudden we had a set of tools for controlling east-west traffic and for getting visibility into east-west traffic that had really not existed previously. And the idea of building sort of zero trust networks had existed for a long time, but it had been technically very difficult to pull it off. And so this was one of those kind of things where we had the right technology at the right time to solve what became a very pressing problem. And so all of a sudden we went from having sort of tens of large, sophisticated customers to having sort of hundreds to thousands of customers of all different shapes and sizes from all different industries. And I'll show you some examples of that in a moment. So the security and microsegmentation use case kind of took us over the hump from a technology that you had to be pretty advanced to see the value to a technology that a lot of people could appreciate. And then more recently, as we've started to extend NSX from single data center deployments to multiple data center deployments, what we've now seen is an increase in the use cases around application continuity, which means things like making disaster recovery much easier so that you can move from from say your primary data center to a backup data center and do that without interruption or with much lower downtime. Because just as I showed you in that picture a minute ago, a virtual network is now a lot more like a virtual machine. So you can snapshot it, you can copy that snapshot to your backup data center. Now when you have to do a DR event, you can bring up that virtual network independent of whatever physical hardware exists in that backup data center. So this whole idea of having networks that are provisioned in software, can be treated like just a bag of bits and carried around, creates all these other opportunities. Thank you so much. So, those kind of three broad categories have kind of driven us from the early days to where we are today, and that kind of leads to the sort of just the market acceptance reflected in this slide. So these are numbers as of about a month ago, where we had reached the point of having over 1,400 customers having purchased NSX and almost 350 customers having put NSX into production. And quite a large number of customers at this point are at the point where they've spent over $1 million with NSX. And in many cases, that's because they might have started with some small project and come back and bought repeatedly to hit that threshold. But so these are not necessarily just little proof of concept type deployments, but actually kind of big substantial deployments. So it's kind of turned into a pretty significant business. And the interesting thing about this logo slide is that the companies here kind of span so many different verticals. And that, I think, just reflects the fact that those use cases are now extremely broad. So if you looked at where we were sort of 4 years ago, mostly you had to be quite technology savvy to see the value of NSX, whereas now we've got retailers, we've got school districts, we've got financials, and all kinds of different healthcare companies, all kinds of different verticals, seeing the value of one or more of those NSX use cases. So that's kind of what has driven the interest, and we're seeing this rate of growth now being pretty dramatic because that customer number, while it's quite large compared to where we were a year ago, still quite small compared to the sort of total addressable market. If you think about sort of how many tens of thousands of customers potentially out there have problems that we could address with this. So I'll pause for a little bit. Any questions or comments on that intro? All good?
I'll do a question in terms of audience. I know early on, a lot of customers were on the cloud teams and whatnot. Are you seeing a larger shift in terms of customers that are doing the POCs and testing, shifting from systems teams, cloud teams to more traditional network teams that are testing NSX?
Yeah, that's an interesting question actually about sort of what's the sort of profile of the type of group in a company that goes and looks at NSX. It's quite broad at this point, I would say. So certainly in the early days, it was people who were building a cloud. They had a cloud team. They were the kind of people who could sort of consume this technology that was really it was not exactly a traditional networking technology, but not a traditional compute technology either.
Right.
So today it's pretty broad. So sometimes it'll be the virtualization team will be the one that sort of brings NSX in. In many of the bigger deployments, it's a collaboration with the network team that you're not going to bring in something this significant from a networking point of view without involving the network team. So I think I may have a slide coming up later where we talk about the sort of different levels of maturity that we see across different customers. So at the sort of the low maturity end, you'll see customers who are still pretty siloed. So they've still got a network team, a storage team, a compute team. At the other end, you'll see customers that have kind of a cloud team that's got representatives from all of those different silos. We do see people sort of not generally being at the very bottom of that maturity scale, but nor are they all at the top. So it's a real mix. But definitely for the bigger deployments, we do see the network team getting involved.
Are you seeing a lot of smaller deployments? It still seems like it's a lot of great logos up there, but even for SMB shops with a handful of racks, that from a DR perspective, it seems almost like a no-brainer, right? Are you seeing a lot of adoption in that smaller market?
Yeah, there's a pretty good mix across different customer sizes as well. So, for example, we've had like small regional banks, adopting it just for the micro-segmentation.
Okay.
And sometimes even when it's a big customer, sometimes they'll try it in a small environment first. I'd say probably the biggest impediment to getting really down to the sort of the SMB market is the sales aspect of that.
Okay.
We still don't have a really strong sort of channel sales process at this point, and that's partly because technology is kind of new enough that you still need a fairly specialized salesperson to be able to sell it. So that kind of holds us back at the very low end, but we're definitely doing a number of fairly mid-sized customers.
And these numbers, are they MHV or just?
They're across the whole product. I don't think we typically break out the numbers, but I'd say the dominant adoption these days is on V. Any other questions? All right. Actually, we're running nicely through the intro time here, so let me just move ahead here. So this is just a couple of pictures to help really mostly the folks watching this online sort of understand the security sort of game here. So on the left is what is sort of a caricature of traditional security. A lot of effort done to protect the perimeter, but it's just too hard to put a lot of protections inside the data center, and so you end up with this sort of lack of control and lack of visibility for the traffic that's within the data center, and the attacker only has to be right once to get through that perimeter, and then there's been a pretty widely quoted statistic that's the average time between infiltration of the data center and detection of the attack is 205 days. So it's 205 days to play around inside trying to figure out where the credit card data is or the social security numbers. So on the right is kind of the picture of like, well, this is what I would like to try to prevent all of that, all of that east-west traffic from flowing, except it's an operational nightmare to manage, 1,000 firewalls and extremely costly. So that's why people haven't typically done that. So let me just give you kind of a pictorial view of sort of what we can do in NSX that's different. So this is kind of a traditional view where you have, a bunch of different applications from different departments, and you kind of segment them. So you have a DMZ segment that's kind of facing out to the internet, and you kind of just assume that that's a sort of dirty part of the network, and then you firewall that off from the rest of the network. But then once you get beyond that second firewall, it's kind of a free-for-all. And so, if the finance VMs get compromised, then they could start communicating with the HR VMs or something, like that. So the obvious thing that we can do is just put each of those into its own separate network, and that's something that's really straightforward because building virtual networks is what we do. And so now it's it's totally free basically to say finance gets its own isolated network. It has switching, routing, firewalling, but it's completely isolated from HR. And so now if something goes wrong in finance, it doesn't spread to HR. But then beyond that, we can also say, actually, we can put much more fine-grained controls in place within that finance segment. So this is where the idea of microsegmentation comes from. I don't think anybody's totally nailed the definition of microsegmentation, but I feel like you've got to have at least two things. You've got to be able to build a lot of isolated segments, like the nature of them being microsegments is you're going to have a lot of them, and you've got to be able to do fine-grained controls within those segments, which is where the distributed firewall comes in. So an example of something you could do here is say, those VMs on the DMZ facing out towards the internet, their job is to take traffic from the internet and forward it to the applications here. They should not be talking to each other. So if in fact a VM on the DMZ tries to talk to another VM on the DMZ, that is something you should detect and block. And that's exactly what you can do with a distributed firewall. You can say, finance VM on the DMZ can only talk to the finance VM on the app tier, and if it does anything else, raise an alert. So this is why I think it was the combination of what we built for automation plus the distributed firewall that kind of put us in exactly the right place at the right time, because now we've got a level of fine-grained control that didn't exist before and the ability to see what's going on. So, you've probably heard a lot about the Target hack and how various alarms were going off over the course of the sort of few months that the attackers were trying to find the credit card data. But the problem was those alarms were going off whether there was a problem or not. They were kind of just noise. And so to have kind of much more visibility into what's going on gives you this ability to actually make sort of actionable alerts. I mean, it's like, oh, a VM on the DMZ is trying to talk to another VM on the DMZ. That's probably a sign of of some kind of compromise. So let's go and fix it right now, as opposed to waiting 2 months for something to, something bad to happen.
Can you do this, I forget, without logical switches? Can you do the microsegmentation just with VLANs and port groups?
So you can do it without overlays.
Okay.
So you can basically put the firewall rules in place in sort of at the VNIC.
Right,
you don't have to do any other.
Okay.
So you basically could think of it at that point. You've now got sort of it's a single L2 domain
Right.
with distributed firewalling on every VNIC. You can totally do that.
Cool.
I think a good way to think about it is we've just given you a toolkit of kind of all these different building blocks of networking that you can kind of deploy them however you want. So you can put firewalls wherever you want, switches wherever you want, routers wherever you want, and doing that is just a matter of making the right API requests. Okay, so I think I'm running up against the amount of time I wanted to spend here. I think I'll just cover this slide real quick and then move on to the next segment. So the last thing I wanted you to take away about kind of what I think is really special about NSX is that the fact that we have distributed services, it's a bigger thing than just a distributed firewall. So I think I've already given you a good sense of why a distributed firewall was really powerful. Having the ability to put services into every hypervisor and have them distributed across the entire data center gives you really sort of three main benefits. Now we've got scale that's sort of unprecedented. So to stick with the firewall example, it's very easy to find a data center with a terabit of firewalling capacity without a single physical firewall, because we can do 10 megabits of firewalling at every VNIC. So this is extremely scalable, and so as you put more workloads into your data center, you're able to get more capacity for all of these services. So it's just, it's a very scalable way of doing it. Because we're doing it at the VNIC, we're not required to send the packets out to some appliance. So you not only you avoid a bottleneck, but you also avoid the sort of challenges of making sure that your routing topology was correct. Effectively, you've got a better assurance of correctness because that firewall is sitting right next to every VM, so a packet cannot get out of a VM without hitting the firewall. And then the other point there is that sitting inside the hypervisor, we have a lot of visibility into what's going on with the guest itself. So for example, we can create policies based on, say, what operating system version is running, what user is logged into the VM, or what group that user belongs to. So you can now start thinking about your policies being driven by more high-level things, as opposed to just, oh, I saw something in a packet, let me try to figure out what's going on. You can actually say, well, this VNIC is connected to this VM has this properties, I can create policies based on that. So it's a much more contextually aware way of doing security policy or other forms of network policy. And then finally, the visibility. We see every packet as it enters and leaves the VM. That's kind of the nature of being in the hypervisor. And so now, that example I gave a minute ago, you can actually tell when a VM is talking to something it shouldn't. And you can do that on a packet by packet basis. And so I'll show you in a demo in the next section of some of the things we can do with that enhanced visibility. And so this has become, I think, a really important aspect of security. It's not just to be able to block the traffic, but it's actually to be able to know what's going on and to be confident that when you're getting an alert, it's meaningful, as opposed to the kind of, the sort of the noise of constant alerts that are sort of inferred from incomplete data. So when I think about kind of what's unique about NSX, it's the fact that we can insert all of these services right next to where they're needed. That gives us a lot of power. And so we see distributed services building on the firewall. So things like distributed firewalling, you get, you add to that distributed load balancing, distributed encryption. We already have distributed routing. So all of those things become kind of examples of what you get because of applying the services in the hypervisor.
NSX has different components, automation, security. So what do you hear from organization and customer that deploy NSX? They have to break up the silos and then put everybody to work together. For example, the virtualization team, the security team, network team. And if an organization is starting to think about deploying NSX, what do they need to do to prepare the teams to work together to successfully deploy their product?
Yeah, so this is definitely one of the challenges that we're really trying to get people to focus on, is that if you don't make any changes to your operational model, you're probably going to struggle to get all the benefits that NSX brings. And so, for example, if it takes you a long time to provision a VM today because there's so much process involved in getting somebody to sign off, you're not going to suddenly be able to provision a network quickly either. What we've done is we've kind of studied the way our customers have deployed this successfully, and there's kind of at least two models. One is people actually build a blended team. They have like a cloud architect who has people from all the silos reporting to him or her. Or the sort of less extreme model is you have a cross-functional team that's responsible for getting things done, but they still report into traditional silos. So you have somebody from the network team, the virtualization team, the storage team, kind of working together to sort of make this transformation without necessarily breaking down the silos completely. So that's kind of the two models that we see. I think, obviously the completely siloed model is something that is going to be a drawback or an impediment for people trying to do this. I think the The other thing is that in some cases we see, like, say, traditional networking people sort of leaping at the chance to expand into a new area. So, we see people with, been trained as, CCIE or something like that, going and getting a certification so that they can be a virtual networking expert. And that obviously helps a lot if you have somebody who's got expertise on both the physical networking side and the virtual networking side.
I don't remember the entire partner ecosystem with NSX off the top of my head, but as far as like passive taps and things like that, I think Gigamon has got a solution for for NSX. Is anybody else that you're aware of doing anything like that?
So we do have a really large ecosystem, and I think I've got a slide coming up actually. So I'll try to hold off on that for a minute, but we expose the northbound APIs of NSX to pretty much anybody who wants them. So, given that, for example, you can say, I want to get this port spanned using an API. So anybody who wants to do that can do it and suck it into their tool. You can also get NetFlow data exported. And then, so sort of passively tapping traffic is something that sort of we natively do in the product, and then a third party can just consume that data and do what they want with it. So Gigamon is definitely one of our partners. And then we have companies like Arkin who look at the information that we give from the virtual, and then they go and look at what they can get from the physical and bring it all together in one pane of glass. So you actually